Hello, I am Gil-Jong Kim from Samsung Research Data Service Lab and Samsung Electronics. Very glad to meet you all here in SDC24. 2 years ago, at SDC22 held at Moscone Center, we unveiled the Samsung Health Stack in an all-in-one open source project that supports digital health research using wearable devices in Android and Wear OS environment through our tech session and code lab. Since then, the project has made steady progress based on the continuous efforts of researchers at Samsung and our partners utilizing the Samsung Health Stack. Accordingly, beta version was released in March 2023. Version 1.0 was released in June 2023, and version 1.1 released in June 2024 subsequently. Reflecting the rebranding introduced in the previous session, it was renamed as Samsung Health Research Stack last September. Simultaneously, the new beta release was published. In this session, I will introduce the direction of change pursued by the Samsung Health Research Stack and highlight the newly added features. Additionally, I will present some clinical study cases that have been or are scheduled to be conducted through the Samsung Health Research Stack. As with major version updates, our 2.0 update brings several important changes. First, the rebranding. As mentioned in the previous session, a new Samsung Health SDK suite was introduced to better support developers and researchers in creating innovative healthcare solutions. In accordance, the revamped Samsung Health Stack is now Samsung Health Research Stack. The addition of research emphasizes our goal of supporting and nurturing the digital health ecosystem. However, despite rebranding, the Samsung Health Research Stack remains true to its essence as an open source project, and its commitment to leading the establishment of the digital health ecosystem in the Android community remains unchanged. Under this direction, the past 2 years were spent to reflect requests collected from the on-site applications, and we made great strides in all components of the Samsung Health Research Stack. Let us first introduce the changes made to the App SDK component. Sungjae, one of our best developers, will explain in detail. Please give him a warm welcome.
Hello, I'm Sungjae Choi from Samsung Research Data Service Lab, working with Gil-Jong. First, I'm going to introduce the key differences about App SDK 2.0 of the Samsung Health Research Stack. When we introduced the Samsung Health Research Stack and presented it at events such as SDC, Health, and HIMSS, the most frequently asked question was, does this mean I can easily collect data from Galaxy Watch? Our answer to this question used to be a little bit away from confident. We could only respond something like, yes, it's possible, but you need. But now, with release of Samsung Health Research Stack 2.0, we can confidently say, yes, absolutely. Since the 1.0 version, the Samsung Health Research Stack has supported the Health Connect interface. Health Connect is now included in the Android operating system. So with Health Connect interface, Samsung Health Research Stack can be utilized on all Android devices, not just for Samsung devices. In 1.1 version, we added support for the Samsung Health Privileged SDK which is now referred as to Samsung Health Sensor SDK. It allows users to access raw sensor data from exclusive to Galaxy Watch. For the 2.0 update, we'll provide the integration with the soon-to-be-released Samsung Health Data SDK. This comes from a shift towards the Samsung Health SDK suite. This means that all Samsung Health data and all sensor data from Galaxy Watch can be collected with Samsung Health research stack. For example, sleep data collected through the innovative Galaxy Ring can also be utilized with researches if you are using the Samsung Health research stack. Another key feature of the App SDK 2.0 version is support for wearable standalone app. Previously, this functionality was not a part of plan for Samsung Health research stack, but we recognized its necessity through feedback from researchers. So now we introduce the new wearable standalone mode. Digital health research is highly diverse and complex. As a result, the required data types also varies for each study. If a particular study focuses more on the raw data of wearable sensors, it will be much more efficient if the research is performed without mobile device and only wearable devices. This not only reduces the purchasing cost of devices that need to perform studies, but also makes study management much easier. With the Samsung Health Research Stack 2.0, users can create easily create a standalone wearable app for such cases, working with the Samsung Health Research Stack backend system. The App SDK 2.0 also includes numerous other improvements. One of the biggest challenges when collecting data using wearable devices, like Galaxy Watch, is managing limited battery capacity effectively. For example, if the Galaxy Watch is used for study and it needs to be charged for every few hours, it is nearly impossible to guarantee steady data inputs. The Samsung Health Research Stack 2.0 is the result of extensive experience and expertise in determining the optimal form for maximizing battery efficiency in terms of storing data, frequency of data, and transferring the data. Furthermore, App SDK 2.0 supports wearable device status recording. This equips reliable data transmission functionality and provides a wider range of data type measurements. By leveraging these updates, we are confident that it will be much easier and more convenient to create mobile and wearable apps needed for digital health research. So these are the core changes in the Samsung Health Research Stack App SDK 2.0. Now, let's go to the behind the scene, the backend system of Samsung Health Research Stack. One crucial characteristic of Samsung Health Research Stack open source project is that it encompasses all components necessary for digital health research. Not only does it provide an app SDK that enables easy creation of applications, but it also offers a backend system that centrally manages data collected by the app and a web portal that assists design and management and analysis of data. This makes it easy to set up a digital health research environment that uses the wearable devices and the data from Samsung Health Service. The backend system has undergone significant changes in version 2.0 as well. The main changes in the backend system focus on improving stability in handling and managing large amount of data. And it's all based on our experience through actual field use cases for Samsung Health research stack. To perform more precise research, the data volume has increased and the participant number has been increased. So data transmission between the measurement devices and backend system has required much higher efficiency than we initially expected. So in 2.0, gRPC protocol is implemented for data communication. However, the other components like web portal needs continuous support of existing HTTP protocol for compatibility and accessibility. gRPC and HTTP, it led us to adopt Ameria, a high performance asynchronous framework based on Netty. As a result, backend system based on the Spring Web Flux now support both gRPC and HTTP simultaneously. Furthermore, data growth calls for database optimization. MongoDB, well-known NoSQL database, is our alternative option for existing relational database. So we did. As you know, MongoDB has a strength on efficient distributed processing and fast writing with its aid of its sharding support. Now, backend system with MongoDB shows excellent performance in processing and analyzing large amounts of data, which makes it easier to develop AI model based on the data. This aligns perfectly with our long-term objective of supporting cutting-edge digital health research. In the previous version of Samsung Health research stack, super tokens was used for managing permissions of the service. But customizing fine-tuned access control was not very straightforward. So Casmin is introduced in 2.0 version of the Samsung Health research stack. Now, you can apply any policy of permission at function level flexibly. If you want to define a new service or to create a new policy, you can do it easily by just adding a simple Casmin configuration and a few lines of code. Attaching annotations to the desired functions is enough to implement the access control what you want. The Samsung Health research stack is using reactive programming paradigm. As you know, reactive programming paradigm is not very straightforward. If you are new to reactive programming, you should get used to something like reactive operators, value subscriptions, and so on. These elements come together to form complex workflows, which can be a bit daunting at first time. We experienced such a learning curve during our first 1.0 development. However, as you know, Kotlin coroutine-based programming could make it easier. Please take a look at the codes at the screen. As you know, the naive reactive programming above and the Kotlin coroutine code below both work asynchronously. However, Kotlin coroutine-based code is much more readable and familiar, unlike the naive reactive programming. To take advantage of this, we refactored most of our reactive code into coroutine-based one. I expect that now you can utilize the backend system code more comfortably. Next, Gil-jong will continue by introducing the improvements in the web portal of Samsung Health research stack. Gil-jong, back to you.
Thank you, Sung-jae, for your detailed explanation. Great job. The web portal also has significant changes in 2.0 version. Actually, it has been completely rewritten. The dashboard has undergone the most meaningful changes. Researchers can now easily check data collection statuses and perform simple analysis through this new dashboard. Previously, research managers could only view visualizations of specific data types in predetermined formats. Now, in a notable upgrade, they can customize and view any data they desire in the format they desire. With selecting appropriate data from your study, writing a relevant query, and choosing the desired type of data, type of chart. You can then visualize the data like it's shown on the screen. These charts also have a feature of real-time updates. Set your preferred chart refresh time and check how data collection is going on. Currently, it supports 5 types of charts and basic data flows. Actually, we are continuously improving it so that ultimately no coding would be needed to adjust chart details, just the buttons. These features will become more convenient and more powerful. Most of changes in web portal were made based on the feedback from the digital health researchers. We focus on enhancing functions that are convenient for them to use. So we made significant improvements to the research design, creation, and management functions. So now you don't need to write down the data types you want to collect in your research app codes. Just specifying your data types when creating a study on the web portal. This ensures that your app collects the data you need for your study. On the other hand, it is entirely possible to conduct studies with varying data requirements for each study with using only a single app. What I'm telling you is you no longer have to rebuild the app for each study to adjust the data types. We will also have easy access to study data. We implemented a function to upload and manage additional data other than those collected by the application. Store your data in the familiar file system-like structure. Check the data in your browser and download it. If your backend is connected to the cloud storage services, you can easily download and upload using it with pre-signed URLs created from backend without any credentials. Furthermore, you can customize the educational contents freely. In case of a need for training content for study participants, the web portal provides a route to create an educational content in a free form. With that, the participants can easily learn about the study. As you can see, these changes in the Samsung Health Research Stack do not merely implement ideas from our developers. Once the beta and 1.0 versions were released, clinical studies using the Samsung Health Research Stack were conducted not only within Samsung Electronics, but also in various external institutions. In particular, the unique and precise data obtained through Galaxy Watch sensors is in high demand among digital health researchers. The Samsung Health Research Stack allows researchers can collect a wide range of unique data, including PPG signals, body compositions, accelerometer metrics, and test results from the study. Through resolving unexpected situations, we uncovered overlooked requirements. Using feedback from those experiences, we could improve and complete the health research stack. At our first review at SDC, we focused on startup use cases. This time, I will demonstrate some clinical trial applications. Besides raw sensor signals, sleep sessions, stages, and scores from the Galaxy Watch and Galaxy Ring on the Samsung Health service are an invaluable source of data for digital health researchers. Bayer AG, a global leader in pharmaceuticals, recognizes the significance of the precise and readily accessible sleep data provided by Samsung Health service. In fact, Bayer is currently leveraging the Samsung Health research stack to collect participant sleep data from the Samsung Health service as part of its observational study plan named STEAM. This study aims to improve the understanding of the burden and impact of the study disturbances associated with menopause. Furthermore, numerous hospital research teams all around the world are either using or considering to use the Samsung Health research stack for their digital health studies. Some studies focus on raw sensor data exclusively available from the Galaxy Watch, while others utilize unique data from the Samsung Health service. Samsung Health research stack plays an instrumental role in helping establish easily these diverse research environments. So now we are taking off with more and more research cases using this amazing tool. It just keeps getting better and better. This project is all about growing the digital health research ecosystem and discovering new biomarkers and technologies. We need your help to make it happen. Please keep sending us your ideas and contributions. And every pull request, big or small, is important to us. Let us make a difference together. For more details, I highly recommend visiting Code Lab, prepared by my colleagues. So there, you'll be blown away by how easy it is to set up a data collection environment using the Galaxy Watch in just 10 minutes. I think for talented developers like yourselves, I'm sure 5 minutes will be enough. Don't miss out and drop by to see for yourselves. That's all I have prepared for today. Thank you for listening, and I hope you enjoy the rest of SEC. One more thing. If you have any questions, please come to our meetup time right after this session. Yes, thank you.